day, everyone. My name is Erogo Oboyo, a former mathematics teacher and mathematics teacher at Dayspring Christian College. Yeah. I'm going to be talking on the topic binomial theory. I'm going to be teaching on this topic. And this actually comes to play where we have some algebraic expression that needs to be expanded. And that's going to bring us to using the Pascal's triangle. That's my point of view here. Now, for instance, given an algebraic expression of this form, you could be asked to expand this algebraic expression x plus y raised to power 3. Already looking at this, by the normal way we expand, we should know that this is actually equivalent to x plus y into x plus y into another bracket x plus y. And it entails breaking this down. I will have to simplify this first of all by doing this x plus y. This simply means that I'm going to simplify this by multiplying whatever I have in this first bracket by whatever I have in this second bracket. And how do I go about that? This simply means that whatever is inside this first bracket must multiply whatever is in the second bracket. So I'm going to break it down. X is going to be multiplying everything in this second bracket, and we have this x multiplying everything in this bracket plus y, open bracket, x plus y. What am I doing? I'm simplifying these two first of all, break that down, and this means x times x gives us x squared, x plus y, x times y gives us plus xy, plus y times x gives us plus xy, and plus y times plus y gives us plus y squared. Now if I'm to merge this together, I can see that it will be easily simplified as this. Xy plus xy gives me what? 2xy plus y squared. Now you will observe that the coefficients of x squared and y squared are 1 respectively. That's what we have it to be. So in other words, what I've just done is that I have simplified this. I've multiplied these two brackets. Now I'm left with this. Now this brings us to this point where we've been able to simplify these two expressions. Now coming to this, I have to use whatever I have here to multiply this last term, which is x plus y. So I'm simply going to write this. 1x squared plus 2xy plus 1y squared, all in the brackets, this is merged already, times x plus y. What does this entail? It simply means that whatever I have in this first bracket multiplies everything I have here. Or you can take this first of all. Whatever you have in here multiplies everything here. So I can simplify this by writing this. X multiplying everything here, I'm going to bring it out. X open bracket, 1x squared plus 2xy plus 1y squared, close bracket. Now I'm done with this. Plus y multiplies everything here. So I'm bringing out plus y, multiplying everything in the bracket, 1x squared plus 2xy plus 1y squared. Now I can now simplify. To simplify this means x times 1x gives me 1x cubed. X times plus 2xy gives me plus 2x squared y plus x times 1y squared gives me what? 1xy squared. I'm done with this first bracket. Now I'm going to simplify this in the second bracket. Plus y multiplies everything here. So plus y times 1x squared gives me plus 1x squared y. Yes, plus times plus gives me plus. So y times 2xy gives me 2xy squared plus y times 1y squared gives me 1y cubed. So simplify this further. I'm going to be collecting the like terms. I'm done with this. What looks alike, you can see that this and this, they look alike. And by the time you sum up this and this, I'm just going to write it out so that it will be very obvious. I'm collecting the like terms. Take it. 1xy squared, 2xy squared, then finally 1y cubed. So let's simplify. This is 1x cubed. This gives us plus 3x squared y plus Merge this gives us 3xy squared plus y, 1y cubed. Now what I chose to show my coefficients of x cubed and y cubed here, I'm trying to come to something that brings us to Pascal's triangle. What does it do? It actually gives us an array of the coefficients of these things: x cubed, x squared y, xy squared, and y cubed respectively. Now, given a problem like this, where you are asked to use the Pascal's triangle, using Pascal's triangle, let's see how this can be simplified. Expand the binomial expression x plus y cubed. Times like this, what do we do? Now, the Pascal's triangle actually gives us an array of the display of all these coefficients, and we're going to be seeing how that works now. Now, this is the Pascal triangle. How I derive it? 1, take it to the left, 1, take it to the right, 1. Now, I'm going to be expanding this. Same thing happens here to my left, 1. Now, I'm going to be summing up whatever I have here. Gives me 1 plus 1 gives me 2, and out here I have 1. Again, I'm bringing it out again. This is 1. Merging these two together, this gives me 3. 1 plus 2, 3. 2 plus 1 gives me another 3. And I'm bringing out 1 again. I'm also going to bring this out again. I'm still expanding. 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. And I'm bringing out 1. You can observe that we are having a symmetric order of the display at every level. I can still go further. 1, 5, 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5, and I'm going to bring this out again. 1. They all have a symmetric order. You can understand that. And another thing you must observe about this Pascal's triangle is that at each stage, you can actually get the next stage from the preceding stage by simply splitting it out on the symmetric form and adding up the internal terms that you have. And how does this come to play now? I want to see it in reality. Given an expression like this, at this stage, I'm going to take this as my power 1. Power 1, 2, 3, 4, 5. But as far as this question is concerned, this is where I'm concerned about. Where I have my power of this expression to be 3. And on that note, I'm going to have that the coefficient of x plus y raised to the power 3, the coefficient of x plus y raised to the power 3 is given as, from this Pascal triangle, because I said that the Pascal triangle actually shows us the coefficient of each of all these terms. So these are the coefficients that are actually represented. So you can see that the power of 3 is at this level, power. So the coefficient of x plus y raised to the power 3 with respect to this power is going to be taken from 1, 3, 3, and 1 respectively. Now let's see how this works. We are going to the expansion proper. Note, at this stage, while we are considering the expansion, what happens? The coefficient of x, while the coefficient of x decreases, the coefficient of y is going to be increasing. Now let's show how that works. So let me write this down. Note, coefficient of x decreases y, the coefficient of y increases. Now let's show that. Good. Let's expand x plus y cubed. Now using this now, you can see that we are considering this level of the power. So what should be the first coefficient of our x? The coefficient of x should be 1. Where we have x, we said that, remember that we said that the coefficient of x decreases while the coefficient of y increases. So considering this power, x is going to be taken on the first power, 3. Y is at a low level, 0. That's what happens. Plus, why are we having a plus here? Because of this sign here. The next stage now, remember we said that while the coefficient of the power of x increases and decreases, the power of y increases. So at this stage here now, what will be the coefficient of this algebraic expression? It's going to be 3, right? I'm done with 1, I'm going to 3. 3x. At this stage, x was raised to the power of 3. Remember, the power of x diminishes, right? It decreases. So we have raised to the power of 2. Y that of y increases 1. Plus, we are done with this coefficient. We are now here. The coefficient of this algebraic expression is 3. 3 again. X raised to the power of, while the power of x decreases, this is going to be 1. The power of y increases. Plus, now we are here, 1. Coefficient 1. The power of x still decreases, diminishes to 0, while that of y now takes on the initial power which we started with, which is 3. Can you see that? So at this point, we've been able to expand this using our Pascal's triangle. Now let's compare whatever we have here with whatever we have there. I can as well write this as 1x cubed y raised to power 0. Remember that anything raised to the power of 0 is equal to 1, obviously. Plus 3x squared y raised to power 1 is y, plus 3x raised to power 1 is the same thing as x, y squared plus 1 x raised to power 0 again, it's also 1. Because anything raised to power 0 is 1, and y raised to power 3. So this is the same thing as saying 1x, I'm still retaining the coefficient of our algebraic expression, plus 3x squared y, plus 3xy squared, plus 1y cubed. Now can we compare this and this? Comparing these two equations, 1 and 2, you observe that we arrived at the same answer. And I can say that this is actually a less cumbersome way of solving or expanding our binomial expression. Thank you.